Hello. In this video, we'll be talking about the geometry of linear transformations. We give the following definition. A function t between v and w is called the linear transformation between two vector spaces v and w if it preserves both vector addition and scalar multiplication, which means that the result of the action of t on the sum of vectors v1 and v2 will give us the sum of images of those vectors in the space W, T of V1 plus T of V2. Likewise, T applied to the product of a scalar K and the vector V1 will give us the product of a scalar K and the image T of V1 of the vector V1 in the space W. And this should hold for all V1 and V2 in the vector space V. Next, we'll give an important theorem which is describing the structure of linear transformation in the Euclidean plane. Theorem is formulated as follows. A function t from R2 to R2 is a linear transformation if and only if there exists a 2 by 2 matrix A such that t applied to V is given by the product of the matrix A and the vector V for all vectors V in R2. Next, we give the definition, which is also related to this theorem. The matrix A in the above theorem is called the standard matrix for T, and its two columns are T applied to the vector 1, 0, which is the first basis vector in R2, and the second column is T applied to 0, 1, which is the second basis vector in R2. And finally, we will give some examples of linear transformations. So the first example will be the linear transformation which reflects vectors about the x-axis. The second will be reflecting vectors about the y-axis, and the third will be reflecting the vectors about the line y equals x. So these transformations are given respectively by the matrices A1 about the x-axis, A2 about the y-axis, and A3 about the line y equals x. Thank you very much for your attention.